Section 7.2 is adding and subtracting polynomials. Basically, what you're doing in this section is combining like terms, okay? So this should not be too complicated. Just remember, like terms are monomials are terms with variables that have the same exponents. So just to give you a couple of little examples, 3x to the fourth and negative 2x to the fourth. These are like terms because the variables have the same exponents. So I can add and subtract these two monomials with one another. However, 3x squared and 3x to the third, I can't do anything with them because the exponents are different. Even though the coefficients are both 3, I can't do anything with them because the exponents are different. It's just a little so these are like terms. Yes, these are not like terms. All right, now with that being said, we're just going to add some polynomials together just to kind of get to the point. There's really multiple ways that we can do this. I particularly like what we call a vertical method, which I'll show you in just a minute, and I just find that particularly easier. One of the ways, so let's just get to it. I have 2d plus 3 plus 4d minus 6. What I'm actually going to do is I'm going to take this whole polynomial and I'm going to actually put it under the bottom here. And notice what I do. I line up my like terms in a line. So 2d and 4d, since they're like terms, I put them in a vertical column. And the same thing with my 3 and 6, they're in the vertical column. And now I'm going to add it. So I have 2d plus 4d gives me 6d. 3 plus a negative 6 gives me a negative 3. I'm done. I found the sum of that one. Now let's do this next one together. Let's do that one. So I have 5m squared minus m plus 2. So I'm going to combine like terms. So I'm going to put my plus out here, and then I'm going to go 3m squared. And then I notice in this particular one, I don't have an m. So what I'm going to do is I'm going to put a placeholder there. I'm going to put 0 in the place of this one. And then I'm going to put my plus 10. What I've done does not change this polynomial at all because 3m squared plus 0 plus 10 is 3m squared plus 10. I just put a 0 in the place of this position because I need to make sure that everything else in my column is lined up correctly. All right, now that I've done that, it's just a matter of adding it up. So 5m plus 3m squared gives me 8m squared. Negative m plus 0 gives me negative m. And 2 plus 10 gives me 12. I'm done. All right, I'm going to do 4 with you just because there is a little extra step into this one. So I want you to look at this one. We have 4c squared minus 8c plus 7 plus c to the fourth plus 11c minus 3. What do you notice about this particular one? In this particular one, we have a c to the fourth, and this one does not. So we actually need to kind of rewrite some things. So if we were to start with this one, I'm actually going to start with my polynomial with the highest degree. And I'm going to rewrite this thing to say c to the fourth plus 0, because we don't have a c to the third in either one of them, plus 0 plus 11c minus 3. So this would be my c to the third position. This would be my c to the second position, 11c minus 3. I have not changed this polynomial at all. I just put some zeros as placeholders to find my other, where my other degrees were at. Now that I have that, I'm going to do a plus, and since these are adding, it's just a matter of putting this in. So I have 4c, so 4c squared would go here, and all of these would actually be 0, minus 8c plus 7. So I had to kind of get all my terms lined up in a column correctly. And since I have this addition, we can use the associative property of addition. It doesn't matter which direction I'm adding. So let's put this together. C to the fourth plus 0 is c to the fourth. 0 plus 0, I'm not even going to write it. 0 plus 4c squared is 4c squared. 11 plus a negative 8 is going to give me a plus 3c. Negative 3 plus 7 gives me a plus 4. I am done. All right. Why don't you try number 3 on your own? All right. What you should have gotten was negative 7t squared plus 3t minus 8. All right. Now, this next one, we're going to do the same concept here, but this case, I need to set this up. Notice that this one has a negative 2, so we've got to rearrange some problems here to make this right. So, I am going to go 3s plus 4, and I'm going to put a 0 right here to be in the place of my s square. So I haven't changed this one at all. Now, we do have a little bit of an issue with this next one. We have a 6s squared, so we can plug that here. Oops. And then we have a minus 2s, so we can plug that here. And then we could put our 0 at the end because it doesn't have a single piece. Now that we've kind of expanded things out, it's all in the proper setup, we can actually subtract. We've not changed any of these terms or these polynomials, we just put 0 as a place value. Now that we've done that, let's start working. 0 minus 6s squared is a negative 6s squared. 3 minus 2s, 3s minus 2s is actually going to give me a positive 5s. All right? And then 4 minus 0 gives me 4. Let's try the next one out. We're going to break this one out. We have 9w squared. I'm going to put a 0 in the place of w minus 5. All right? We're going to combine our terms here. We have 4w squared plus 9w plus 7. Subtract things out. 9 minus 4 gives me 5w squared. 0 minus 9 gives me a negative 9w. Negative 5 minus a positive 7 gives me a minus 12. All right? Let's do this next one. Same concept. We have y squared minus 6y plus 12. I'm going to put negative 3y squared minus 6y plus 10. And I'm going to put my minus on the outside. Let's do it. Y squared minus negative 3y gives me a negative, sorry. That's going to give me a positive 4y squared. Negative 6 minus a negative 6 gives me 0. And 12 minus 10 gives me a plus 2. So this one can be rewritten as 4y squared plus 2. Why don't you try number 8 on your own? What you should have gotten for number 8 was 8z cubed plus 2z squared plus 7z minus 5. All right, number 9. You are installing a swimming pool. Write a polynomial that represents the area of the walkway. Wow, so this one is actually kind of complicated. So here we have our pool, and here is our walkway around it. We need to know the area of just this lightly gray thing. So there's a couple of concepts here. First off, we need to know the area of the pool. We need to know the area of the pool. Then we need to know the area of the entire, we'll call it the deck. All right, we'll call it the whole deck, whatever, that'll be fine. And once we know those two things, we can subtract it. We can say the area of the deck minus the area of the pool is going to give us the area of the walkway. All right, so that's going to give us the walkway. So the walkway is equal to the deck minus the pool. So there's a lot of things going on here. So let's find out what the area of the deck is first. All right, so the whole deck area. So we'll put deck is equal to length times width. All right, because this is a rectangle, we're going to say 2x plus 6 times 10x, okay? Cool? So once we do that, we basically use the distributive property. We're going to multiply this 10x by 2x, and we're going to get 20x squared. And then we're going to multiply it by 6, and we're going to get a plus 60x. So the area of my deck is 20x squared plus 60x. All right, now let's find the area of the pool itself. Well, that's going to be 8 times 6x minus 4. Let's work that out. 8 times 6 is going to give me, I double check myself. It gives me 48x, and 8 times a negative 4 will give me a 32. So the area of my pool is that. Now that I do know this, I'm going to subtract the two things. I'm going to say 20x squared plus 60x, and I'm going to subtract 48x minus 32, just like we did before. So I'm going to set this up as 28x squared plus 60x plus 0 for my little placeholder. And then I'm going to do the next one as 0 plus 48x minus 32. And I'm going to subtract them. 20 minus 0 gives me 28x squared. 60 minus 48 gives me plus 12x. 0 minus a negative 32 gives me a positive 32. And I am done. So this required a couple different things. It required you to know how to find area. It required you to understand how to do multiple shapes. It required to know a little bit of distributive property. And of course, some new adding and subtracting of polynomials. And that's it for this video. And I will see you in the next one. Bye-bye.